Well, hey everybody, welcome back to The Humble Horologist, where we take a calm and curious look at the timepieces we love, without pretense, hype, or snobbery. Today I want to talk about something that struck me recently that actually surprised me. It has to do with the lume on our dive watches, how bright it gets, what actually charges it best, and whether we've been judging the lume with the wrong tools all this time. And to help me illustrate all of this, I'll be using my trusty Orient Ray 2, my favorite Seiko, the SRPE 55, and the Spinnaker. Each have lume I thought I understood until just the other day. So pull up a chair, settle in, and let's shine some light on dive watch lume. You know the routine. Whenever a watch reviewer, myself included, wants to show off the lume of a watch, we do one of two things. We hit it with a handheld UV flashlight or, a regular flashlight and hold it there for a few seconds. Then we turn off the lights and see how bright the lume glows. That's the standard test. Everyone on YouTube does it. It's practically tradition at this point. But here's the problem. I noticed something out in the real world that doesn't line up with our flashlight tests. All it takes is just a few seconds of natural sunlight, and the lume on my Orient or my Seiko glows brighter than when I shine my little UV light on it. And the same holds true for other watches too. We're talking a noticeable, immediate difference, day and night, literally. And that got me to thinking, are we shortchanging the lume of certain watches because we're charging them with the wrong light source? Maybe some lume compounds respond far better to the broad spectrum energy of the sun than they do the narrow artificial UV beam. Maybe our reviews have unintentionally handicapped certain watches simply because they prefer a different light source. Let's cover some of the basics, no chemistry degree required. Most modern watches today use super luminova or a similar non-radioactive pigment. Those pigments are photoluminescent. In other words, light goes in, light comes out. Pretty simple. But here's the key. Different wavelengths of light charge lume differently. UV light charges it extremely quickly. Blue light charges it well. Green light charges it moderately. Red light does pretty much nothing. Now here's where sunlight becomes the heavyweight champion. The sunlight contains all of those wavelengths and far more power behind them. Even on a cloudy day, the sun pumps out more high energy light than most pocket-sized flashlights ever could. So even though a UV flashlight might look bright, it's nowhere near the output of that giant nuclear furnace 93 million miles above us. So that's why 10 seconds of sunlight can outperform 30 seconds of a UV flashlight. So let me show you what happened with mine. First, I did the regular flashlight and UV flashlight test. After being inside under normal lighting, I put all three watches in a cabinet and shut the door just to let them rest. After that, I put them in the laundry room and shut the door and turned out the lights like normal, then filmed and took pictures. After doing the flashlight test, I left my watches in the dark for about 30 to 40 minutes to let the charge fade. After that, I stepped outside with my Orient and Seiko and Spinnaker and let the dials face the sun, and not even directly, just in the daylight. Okay, so now you're looking at these three watches in a dark room, the only light being the little light on my microphone on my cell phone. And, there's still lume going on after all this time in the dark. But now I'm going to hit it with 10 seconds of a bright flashlight. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How's that? Is that good enough? You've got the Orient on the right, you've got the Spinnaker in the middle, and you got the Seiko on the far left. After 10 seconds thereabouts with just a normal flashlight. So now I want to take this back into the dark or leave it here for another 30 minutes, come back and hit it with the UV light. As you can see, it's been a little over 30 minutes, and this is a completely dark room. You know, with the naked eye, it's very hard to see, but with a camera, you know, it picks it up a little bit better. But so this is after no light for over 30 minutes, about 40 minutes, I guess. Now I want to add the UV light for, let's say, 10 seconds and see what happens. Five, 6, 7, 8, 9, 10. All right, 10 seconds with the UV light. Doesn't look too bad. Now let's go and wait another 30 or 40 minutes and see what happens. All right, it's been 30 minutes or so. And now I want to take these watches out into the sunlight. Unfortunately, it's not as bright out there than I hoped it would be. It's getting late in the day, and we're just going to see what happens. Okay, there's the sun. It's way over there. Unfortunately, it's not bright high up in the sky. We will see what happens. So here are the watches. I got the Seiko, I got the Spinnaker, and I've got the Orient. There's a cat. That's Maui. So you think it's time to take him back inside and see if this is any different? Okay, I ran back inside, and here is the result of the sunlight. And not on a very bright sunny day, but the sunlight light. So what do we have? I think on a bright sunny day, they're brighter. By the way, this is my 20-plus-year-old Casio MTD 1010. Look at that glow. So what do you think? Sunlight? Is it the clear winner? I think I should have done the test earlier in the day, though. But have you seen this happen on your watches? Have you walked indoors out of the sun into a normally lit room and been amazed at how bright the lume on your watch was? This is what I think. Our standard flashlight test is good, but it doesn't represent real-world optimal performance. Certain lume compounds just prefer the sun. And if we don't test them with sunlight, we might be underestimating how good they actually are. Now, this brings up another question. Does a diver see the same lume underwater that we see on land? Short answer, not exactly. Did you know that? Let's break it down. Water absorbs light, especially reds and oranges. The deeper you go, the more color disappears. Red disappears first, then orange, then yellow. Blue lasts the longest. This means blue lume stays visible deeper. Green lume works well, even at moderate depths. But orange lume looks dull very quickly underwater. That's why most dive watches use green or blue lume. They're not doing it because it's trendy. They're doing it because of physics. Secondly, the water filters out ambient light, making lume look brighter. Underwater, especially at depth, the environment becomes darker and our eyes adjust. That means Same lume plus darker surroundings, perceived brighter glow. Third, a diver sitting in the sun charges lume better than anything else. This is the part I love. If a diver is sitting on a boat deck for 20 minutes before a dive, their watch is getting absolutely blasted by sunlight. When they finally drop into the water, their lume is at peak performance. So what does this mean for watch reviews? Watch reviewers, myself included, often use UV flashlights because they're convenient, they're easy, they produce consistent results. But here's the problem. They don't always show the full potential of the lume. A watch that looks average under a UV light might actually glow spectacularly after a few seconds of sunlight. So maybe, just maybe, we need to rethink how we judge lume. What if we tested lume fresh out of natural daylight, we noted which light source a watch responds best to, and we stopped relying on the UV flashlight as the only baseline? This wouldn't replace the traditional test, but it could add to it. It certainly would tell a more complete story. So here's the takeaway. Our watches are designed to be worn outside. Well, the dive watches at least. Sunlight is the most powerful lume charger there is. Not all lume compounds respond equally to artificial light, and a diver underwater may see the lume even better than we do above. And because of all that, some watches have better lume than we've ever given them credit for. My Orient Ray 2 reminded me that sometimes you don't really appreciate what a watch can do until you take it out into the real world, not just a review table. So in future videos, I'm going to include both sunlight and artificial light lume tests, and I encourage other reviewers to try it too. It gives a fuller, more honest picture of what a watch can do. Hey, if you found this interesting or learned something today, hit that like button. It helps more than you know. And if you enjoy thoughtful, watch-loving conversations, go ahead and subscribe to The Humble Horologist. Thanks for spending time with me today. Until next time, I'm Anthony, and remember, watches are replaceable, but time is not.